Good afternoon, everybody. It is my great pleasure to welcome everybody to this particular Zoom sessions, whereby we are going to focus our discussions and share with you the programs offered by the Department of Physics under the College of Humanity and Sciences. Let me introduce myself. My name is Saw Chong Hao. I'm currently the head of department for the Department of Physics. Together with me today, we have Professor Thomas Osipovich, who is the deputy head of the department in charge of the curriculum and education program. Also, we have Professor Kwek Soo Ying, okay, who is a computational scientist, condensed matter theory scientist, computational condensed matter scientist. Okay, so she does very interesting work. So feel free to direct your questions to her as well, should you have any questions. Okay, so allow me to share some screen and then a few slides to get the presentations going. So can you see my slide? Okay, good. Yeah.
Yes.
So we entitled this talk "Opening Doors with Physics Department with Physics." Okay, and our contact, my email is over there. So it's to let you have further contact points should you have any questions. We have also listed down the email of one of our colleague, Miss Seng. And if you have any further questions after the presentations today, feel free to direct them to her, and then of course she will channel it to us. So we want to spend the first half an hour or 20 minutes or so to try to excite you, to show you why we think physics is cool. It's because we are all physics prof here. Okay? And then I will introduce the department to you quickly. Of course, we hope that you come in and join us and you get to have time to know more about our department. Yeah. And then since we talked about CHS starting this morning, right? College of Humanity and Sciences, and Professor Thomas Osipovich is going to share with you the new revamped physics curriculum structures. Then I'm going to come back to just flash a few slides to tell you what you might be thinking of for career, okay, if you are a physicist. Okay, yeah. So physics, of course, is very fundamental of science, right? You know, right, from what the experience that you have learned before, that we probe very deeply into behavior of space-time, matter, subatomic interaction, cosmology, so on and so forth. So it's a foundation for many physical sciences. And then also, you know that we always have nice, very elegant sets of theory that is able to capture the essence of the physical behavior and then also use it to predict something that's yet to be observed. Now, physics actually is in demand in the sense that, look, Singapore really need the thinker, right? The physicists who are able to contribute to where? The R&D knowledge-based economy, okay? Government research institutions obviously will need to hire a lot of smart people in order to come up with cool solutions to tackle whatever problem they may be encountering. You see, there's an article here by the former Chief Defense Scientist, Professor Louis Baoquan, who really argued that having the ability in science and tech sector is a very important group of people that one should consider training, okay, in order to have a great impact. So I'm going to show you the pictures, right? This is like a family profile of the professors in the physics department. Take a look. Did you get a sense that, wow, this is like international United Nations kind of committee members? Indeed, when we hire our professors into the department, we will ask what is the specialties of the professor. What are they looking at? What kind of problem that they hope to address? Okay? And then you will come to join us in the physics department, you really have the opportunity to learn from some of the best mind, best expert in the field. And they ask very deep fundamental questions and they are very creative. And so by working with them, learning from them, carry out research with them, okay, you are able to also pick up this kind of skill set and at the same time, prepare yourself for a greater challenge in your career in the future. So our professor do very well, win award, okay. Now, we divide our research field, our area of probe, that means what are you looking at, okay, into various areas like nonlinear dynamics, biophysics, physics at a nanoscale, functional material, and a big sector in quantum information and computing. Okay, yeah. So a group of professors working in the area of classical and quantum chaos, okay, trying to understand the interplay between a very complex intercorrelated system and how to govern each other's in terms of the behavior, okay, that you can observe. Like a group of professors, you know, the physics department is special because it's very closely affiliated to a national level center called Center for Quantum Technologies, whereby we have professors probing very fundamental questions on quantum technology, quantum mechanics. Okay, yeah. Then we do have also another group of professors working in the area of nanoscience. Okay, in the biophysics, they probe questions like what is the mechanical property of cells, mechanical properties of DNA, molecular motors. You may ask, this is a realm of a biologist, isn't it? No, this is a realm whereby it's like a interdisciplinary biophysics area whereby you can use the physics tools, concept and law and apply it onto a biological system. And you actually can also learn from the biologists. So this is interesting because you develop interesting understanding, and it's useful because some disease state may have a change in the mechanical biology properties, and then you can tell what's wrong with the patient. Okay, yeah. A large group of us are in the realm of in the field of nanos, including Professor Greg Swing. I forgot to insert a picture here. Yeah. Then we ask questions of how does things change when you have the dimensions reduced. In other words, we live in a 3D world, or actually 4D world plus time. Okay, but especially 3D world. Let's say now if you squeeze one of the dimensions, you can't move in that dimension, so you can only move on the flat world. Okay, how does things change? Well, if you squeeze everything down to you can only move in the line, how does things change? Yeah, so we ask those kind of questions. Things change very dramatically, not just in terms of the magnitude, but it changed qualitatively. So the behavior is totally different, right? And scientists in this area, we ask this kind of question. Yeah. Then we do have a group of professors in the area of theory. Okay, so we don't have a big group, but they are interested in fields like string theory, quantum field theory, for example. Okay, so we have Dr. Wang Qinghai. Okay, so he is interested in quantum field theory. Okay, then he can tell you more about his understanding about this very deep knowledge. Yeah. Okay. And we have an expert in string theory, in black hole. Okay, yeah. So why study physics? Now, do you want to learn from some of the best experts in the field? If yes, join us. Do you want to push the envelope in the frontiers? Probe something that nobody has discovered before. If you like to do that, join us. Do you want to pick up skill set that prepare you to tackle complex problems? This is very good. Okay? We really train you for that. Join us. Do you like to invent things? Be creative. Okay? Do you want to send a beam of fast-moving proton to a piece of crystal and find out more about that piece of crystal? This is what Professor Thomas Osipovich does for his research. It's very interesting. See the instruments there? We do have particle accelerator. Now, even more fun, do you want to investigate whether it's useful to shoot that beam of proton to a cancer patient? Then you ask, wow, is it dangerous? Why would you shoot a beam of proton to cancer, the human being, you know? Proton beam therapy, you want to use it to kill the cancer cells. Okay, yeah. Do you want to control a single atom? We can. Do you want to control a single photon? We have the opportunity. Yeah, so there are professors like Christian Christopher who does this kind of experiment. Do you want to investigate how trapped molecules communicate with the energy field surrounding them? Professor Luo Huanchen, she carried out very interesting experiment to trap molecules and then manipulate them. Do you want to travel to different parts of the world to an exchange program and learn from the local scientists? For example, a picture of Gabun at Yale. He's at the cemetery. Why would he go cemetery? Because that is the tombs of Gibbs. You learn physics, Gibbs energy is one of the big terms that you'll be encountering. So Gibbs is buried there. Yeah. Then you can interact and then work with other students to take part in international competition, come up with cool ideas. So do you want to learn how we can use computer modeling to understand the spread of disease, computer modeling to understand the properties, behavior of atoms and molecules? This is what Professor Greg Swing does a lot in terms of understanding the flow of electron in the systems when you put them together, and then you can use computer ideas, computer models to understand this very well. It's a very powerful research technique. Okay, yeah. Do you want to develop into a person who can pick up new skill set readily and then excel in it? Do you want to develop into a person who can always come up with the cool ideas? Okay, so I will not be able to elaborate in a short period of time, but I want to plant this question into your mind. Okay, so this is what physics training, physics program can prepare you for. Okay, so I would like to now pass the time to Professor Thomas Osipovich to share with you some of the career structures that we are as a curriculum structures that we need to change in order to because of the development of the new College of Humanities Sciences, and then you can see that what are the things that you're going to learn in the 4 years that you're going to be with us. Okay, so let me stop share and then pass the time to Prof. Thomas Osipovich. Yeah. Thomas, you can take over.
Let me share my screen. Where's my share? I hope you can see the full screen now.
Now I see your PowerPoint. I don't. It's still the
Now it should be okay, right?
not yet. This is still in the present. Now okay. Yes. Now okay. Yeah.
Now it's okay. Okay. Yes. Good morning, everyone. I have only a few minutes, and I have quite a number of slides with a lot of text, I'm afraid, because, well, this is the curriculum structure of the physics department. So I want to run through this, at least the major parts, so that you get an idea what's going on. We have, as Prof. So just introduced in the introduction, told us, we have massively revamped study plans and curriculum structure for physics, which is for you very good, because you have many more options now and many more possibilities to engage in physics, as in many ways, as a major or a minor or just maybe a second major. So there's a number of possibilities. Here on the first slide, I show you the curriculum structure, just so that you get an idea. If you want to have a bachelor with honors in physics, you have now to do this type of first year module. This is Frontiers of Physics. Then we have a number of compulsory modules. 6 modules are compulsory. That are prescribed modules: quantum mechanics, electricity, magnetism, classical mechanics. These are the classical major parts of physics that everyone needs to understand and to have a good introduction if you want to call yourself a physicist, or if you want to learn about this. And then you see here we have 32 MCs you have to take. One module gives you 4 MCs, and you can choose among a range of 38 modules here, which go all the way from deeper into quantum mechanics, to atomic and molecular physics, to astrophysics, to statistical mechanics, condensed matter, biophysics, medical physics. So there's a wide range of things where you can engage, and I hope you will do so. Okay. So that's the general curriculum structure. Of course, this is a lot of names to you now, so I will like to show you a bit more of the details. So let me first show you one of the specializations we have. This is in astrophysics. That means you do a major in physics, and then in addition, you can get a specialization in astrophysics when you do things like astronomy, astrophysics, cosmology, general relativity. In order to do that, you have to pass 20 MCs from one of the following modules, and I show this here: classical mechanics, nuclear particle physics, all the topics that you need to understand deeply if you want to understand astrophysics in detail. You can double count 8 MCs with your major in physics. So in order to get a major in physics and the specialization in astrophysics, you have to do only 3 additional modules. Then we have a specialization in nanophysics. This is the physics of a length scale of nanometers, 10 to minus 9 meters, which is of course now very important in industrial applications, microelectronics, a host of stuff where this is very important, and where industrial applications are ongoing and will very likely be increasing in the future. Again, you have to fulfill the normal major requirements to get the major in physics, and then you have to choose 20 MCs from these, which are a subset of our major modules again, and 8 MCs you can double count with the major in physics. So again, you get your major in physics with the specializations if you do 3 additional modules. Then we have a specialization in quantum technology. Well, you've probably heard that worldwide there is a hot race going on to make actual use of quantum mechanical properties. As the computer elements become so small that quantum effects become very important, we cannot just run classical calculating devices anymore. We have to change the working of the computing systems to be quantum computers. And that is an ongoing development. And we have lots of very good professors and research groups here in our department, as in NUS, working on this. And we have created a specialization for that, which follows the same lines of rules like the others. Here are the modules you will have to take for that. Then, in addition to specializations in the minor, we also have a range of minors. Now, what I had before was you take a major in physics, you can do the pure major in physics only, but you can also add a specialization in. That is now the possibilities. If you are not ready to engage with the major, you can do a minor in one of the minors that we are offering in physics. And let me go through them. There's a minor in astronomy. Again, we are looking here at astronomy and cosmology and what is known about the great structure of the universe. The modules are somewhat less rigorous because you have none of the physics background that we expect from the people in a specialization, but it's still a very deep introduction into astronomy and astrophysics that you will get from this minor. You have to take this from this list, the modules that you have to take for this minor in astronomy. Then we have a minor in biophysics. Again, you need to take a total of 5 modules. You can choose them according to this list. So this is possible to read for physics students, for physics major students as well. And of course, biophysics is currently a very important breakthrough area of physics where very important things are being developed and uncovered. Then we have a minor in medical physics. Professor just mentioned that we are shooting at cancer cells with proton beams in our physics department. That is part of medical physics, where we use physical machines, for example, accelerators, to develop techniques to accelerators to kill cancer cells, MRI machines to get images from inside the human body for diagnostic purposes. There's many other applications, imaging, diagnostic, interventional. So we are giving you with this minor in medical physics a first step if you want to make a career or to work in this field. Again, these are the choices you would have to follow if you from these choices you would have to choose 5, this number of modules as described before. Then we have a minor in nanoscience. Again, the large industrial applications are very important, and you will certainly be able to learn enough to work not directly in research, but it will be a first step to give you an insight in how what happens at the nanoscale in materials. And finally, we have a minor in physics. If you are not sure whether physics is really the thing for you, but you still would like to get a very good grounding, then you can choose to do a minor in physics. Again, it's 5 modules you have to take. We have here given you a list of these from which you have to choose. And I think these are very interesting and exciting modules that would allow you to achieve a minor in physics. Finally, we have a physics and technology minor, which is for people who might not want to go in industry for research, but they might want to pursue a career in industry, which is in an industry which is technologically oriented. And for such people, it might be very interesting to have such a foundational grounding in physics to get good insight in how these technologies are developing and what is going on there. Okay. Finally, we have a second major in physics. If you want to do a major in a primary major in another discipline, you could choose to invest 10 modules to do 10 modules and get the second major in physics, which is also a very solid introduction into physics that you could achieve here together with another primary module in another discipline. Now, I want to go very quickly through a few sample study plans with you. I realize these are lots of words on these slides, and you can probably not really absorb all the stuff that is on them. So I would like to direct you towards the physics website, physics department website, where all these study plans can be found. We have now the CHS system. The CHS system allows a lot more choice than in the traditional physics education. So you have many choices to do a single major, a major and a double, and a second major, or maybe a major and 1 or 2 minors. So there's many possibilities. And depending on what you want to do in your career choice, you have to structure your plans in this CHS. And that's why we put this together, so you can have an idea what to take in what time period. Here, the first one is for physics as a primary major. And we have a study plan here that shows you in the 4 years you will be with us, what modules you would have to take if you want to do physics as a primary major. And you see here, the reddish color here is essentially the major modules, and some of them we have actually specified the compulsory ones, and then of course you have many more that you can choose. And then you have other spaces here. You have, of course, the introductory first year modules, which are for all CHS students essentially compulsory, which you will have to take. And then we have all the physics modules here that you have to take if you want to study physics as a primary major. And then we have here a study plan for someone who wants to do physics as a second major. Now it's the reddish boxes here, which show the 10 modules that are to be done for the second major, and all the other choices, of course, for your primary major, and the other modules you need to take are given here as well. Then we have a study plan for people who want to study physics, but they want to go into industry and do a career in industry. So that would be the set of choices we would like to recommend for such people. Again, I will not go through the details. Please have a look at the physics website if you want to look at this closer, and maybe contact me or one of the other counselors to learn more about this if you have specific questions. Then we have a study plan for students who are doing a primary major in physics and they want to go into postgraduate student. They want to do a master or they want to do a PhD, so they want to stay in physics. So of course we want to give them more actual physics and more pure physics and theory modules in such a situation. Then we have a plan here for those who want to go into postgraduate work, but for astrophysics or high energy physics, also for the cutting edge research fields in physics. So this is given here. Again, you can then choose these if you want to aim at such a career. Finally, no, not quite finally, but here we have the study plan for people who want to do postgraduate study, who want to stay in research after the 4 years, and those who want to do condensed matter physics. Again, we have a large set of modules here recommended for in such a situation. Okay, so that were the study plans for major. Now for the specializations that I mentioned before, we also have some recommendations. For example, here for the physics major with quantum technologies specialization, this is given here. What we strongly recommend to take if you have if you want to take this specialization. These are the possible modules you have to choose. I will not go through this, but this refers back to the last transparency. Then we have here for the medical physics minor, there we have different type of study plans for those who have H2 physics or H2 biology. So they need only one bridging module, because if you want to study one of these biology or physics related stuff, so you have to have some kind of university level. So a bridging module is required. That is for this group who have one of the two. Here we have the study plan for CHS students who have neither H2 physics nor H2 biology. So then you will have to take 2 bridging modules. Well, we have both. We have plans for both of these. So we have thought out and planned pathways for you to achieve these minor, even if you have neither H2 physics or biology. These are the details for the modules just listed. Here is the biophysics minor study plan. Again, the one for those who have one of the 2 H2 result from high school. And here we have the biophysics minor for those who have neither physics or biology H2. So again, this can be planned. Your pathway can be planned with this maps. And here we have physics and technology minor. Again, this is for non-physics minor. The study plan for those who are not physics major students. So we have a certain range of modules we recommend for this. And that's it. So, okay, that is it. I realized that was a lot of information I pushed on you in a very short time, but we have only 15 minutes altogether for this introduction. So please, if you have further questions, if you need more details, this is available on the physics department website. And then really think about what you want to do and look at the plans that we have. And we would be very happy if we can offer you some physics education in any of the plans and pathways I have just discussed. Okay, thank you. I now stop sharing and I give the attention back to Prof.
Good. So let me come back. Yeah. So of course there are a lot of information shared, but don't worry, it's all found on the website. But our key point is to tell you that because we want to cater for students with a wide variety of intention in terms of your education's pathway. Yeah, that's why the study plans are all like, in a sense, like customized to students with this interest, with that interest, with that interest. So you take a look and see which are the one that interest you the most, then you can consider following that particular suggestions. Okay, it's just a suggestions because study plan is dependent on your choice, and of course it can vary from there and modify from there. So now imagine now you have a physics degree. What can you do as a career prospect, right? So let me now finish up the final part of the talk before we go into Q&A. So career prospect for physicists. Now, the program itself, okay, essentially train you to be able to solve problem. Okay, so it's a critical scientific thinking training that we provide to the student. So we want you to be a problem solver because we really cannot exhaust the list of the problems that you may encounter in the future. So it's more important to train you the skill set so that you'll be able to use the same skill set to versatilely apply to a wide variety of different problems. So later I will flash to you some of our recent alumni. You see, what are they doing now? In all spectrum of career, they're doing all kinds of interesting career job, okay, and utilizing their skills. Some, of course, you can argue may not directly physics related, but I will argue that the training they have received from us allow them to apply those kind of skill set onto the job. Okay, so problem solving, lifelong learning is very, very important part of the aspect of the learning process. Yeah. Now, if you go and look at the internet, what are the skill set that people were looking for? Now, earlier on in the CHS, there is an employer forum, right? I hope you have picked up a few important advice from the VIPs. They tell you, okay, when I hire persons, we really want the persons to have this kind of skill set. See, the top 10 skill set proposed by the World Economic Forum in 2020. Look, problem solving, critical thinking, creativity, coordination, other emotional intelligence, judgment with decision making, and so on and so forth. And you can see that, I hope you appreciate that, oh yeah, physics training really train quite a number of course, not all 10, but quite a number of the skill set listed down over there. Okay, so what are the career prospects of a physicist? We have so many alumni, it's too long to list every one of them, but we kind of summarized it into this table of pictures. Okay, so you may imagine, right? Yeah. So what does a physicist do? Cutting edge research. Now, this is very interesting. We keep track of our graduate from the department physics program. It's very interesting. Every year, of the order of 25 to 30% of the student after getting their bachelor degree will continue to do postgraduate study, okay, master or PhD, here or overseas. So we have alumni who are doing research now in Berkeley, MIT, Harvard, the famous university, and ETH, Zurich, so on and so forth. They continue to push the frontier. Okay. Now, you see, some of us may be interested in working in the area of environment, climate. So we do have scientists who work with the Singapore Meteorological Service, right, using computer modeling to understand how the spread of pollutions can happen. Of course, weather system is a very important aspect. Now, space. We have a professor who launched the instrument to space. I'm not kidding. Okay, Professor Alex Link. Okay, come here, and then you can learn from how do you put your instruments on a rocket and then shoot it up to outer space. Medical physics, Professor Thomas has already mentioned a lot about this. Engineering. I think I saw one in the chat. There's one question about physics and engineering. Yeah, and the two disciplines complement each other very, very nicely. Yeah, so physics student, we have students who are now working in Global Foundry, Micron. These are engineering company. Yeah, and also of course educations. We have students who are educators themselves, inspiring the young generations of young scientists. Yeah, okay. Energy, right? Physicists are good in harnessing energy in the form of solar cell, batteries. Okay, yeah. And we also can work in the transport. We have alumni who work in LTA, trying to use the modeling to understand the arrival, departure of buses, for example. Not only that, right, in terms of the industrial innovations, you can imagine designing transport system, yeah, that will make it more efficient. Data science, okay, we have professors who work in the area of trying to use modeling to understand the spread of malaria virus in spread. Okay, yeah. So here are some of our pictures of our alumni. See, for example, Joy. Do you think physics and medicines don't mix? Not true. Yeah. She is a medical physicist, helping patients to fight cancer, right? Radiation therapy obviously has been around, and Professor Thomas Osipovich just mentioned about using proton beam to kill the cancer cell instead. Shannon works in the financial service industry. So using his skill set to understand the behavior and flow of different numbers, in this case, perhaps a stock market price, so on and so forth. Yeah. Lok Yan is a material physicist. He's working with a company that deals with coming up with the best processes to come up with the materials with the best performance. Okay. Ken is a consultant. Laurencia is a medical physicist. Okay. And then Kin Lun here, see, using his computer and mathematics skill, okay, to develop different software. Yeah, Jackson is working in the weather, you see. So he tried to understand what's going on in terms of modeling. Yi Chen used her skill set in medical physics very, very nicely. And Chong Ying works in a DNA company. Wait. This is a physicist working in a DNA company? Yes. Okay, so this is how he's able to use his ability to learn, okay, and solve problem and from a different perspective. Okay, so to help the company to advance further. Okay, so that is my last slide. Okay, let me stop share. Yeah, so I hope very quickly you gain a sense about what the physics training program can train you with in terms of preparing you for the future. Okay, so now I'm going to stop the recording so that we can move on to the Q&A session.